Experiment number 2, AND or XOR NOT logical operations. The aim of the experiment is to develop an 8086 assembly language program for AND or XOR NOT logical operations of two 16-bit data and verify it in the laboratory using the given microprocessor kit. We assume that the two 16-bit data are stored starting at 300H and the results to be stored starting at 3010H. So the procedure is same as that of all other experiments. There are 5 steps of procedure. First, we enter the program using the format given in step number 1. We verify the program using the format given in step number 2. We substitute the data required for the program using step number 3. We execute the program using step number 4, and we finally verify the results using the format given in step number 5. So this is the program for AND or exclusive OR operations. So is as normal. So we have the first two lines. First two lines of the program is initializations. We initialize SA register to point the source data. We initialize DA register to point the results or destination locations. Then the next few lines are processing lines. So we move the first data into AX register, we move the second data to BX register, then we perform whatever the operations required, either AND or 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 exclusive OR between AX and BX. The results of this operation will be stored at AX register, as we know. Then finally we want to transfer the results which is stored at AX register to the results location pointed by the DA register. So this is the program for AND or XOR logic operations. And the program for NOT operation is given in the second table. As normal, the first two lines are initialization lines. First line initialize SI register to the data memory, and the second line initialize the DA register to the results memory. Then we have the next two line is a processing line. That means the data from SI register is moved to AX, and the content of AX register is not logically inverted, and the results will be stored at AX. So the results stored at AX as per the aim, so we need to transfer into results memory. The results memory is already pointed by the DA register. So this is the simple programs. So in this we are going to verify all the 4 operations, AND, OR, XOR and NOT operations. Let me give you a simple examples how the microprocessor will do, or let's recall simply. Okay, let's recall how the AND, OR, XOR and NOT operations will be performed. For example, so let's say is assuming the first data is let's say is 1010. Let's assume the second data is 1100. Then when we want to do AND operations, the AND operation is bitwise AND. So the results will be 1 0 0 0 for AND operations, and it will be 1 1 1 0 for OR operation, and it will be 0 1 1 0 for XOR operations. We already studied AND gate, OR gate, XOR gate in the hardware during our digital electronics module. So we are doing the same thing in software. That's it. Okay. Then for NOT operations, there is a data here. The results of NOT operation. Let's say when you take 1010, the inversion will give you 0101 will be the results of NOT. So this is the basic of AND, OR, XOR and NOT. We are already very familiar with that during digital electronics. That the same thing we are performing in microprocessor using the instructions. Now let's go on to verify this program which we have developed. So both in 8086 emulator as well as the 8086 hardware kit available in our laboratory. Let's proceed. So for that we have taken the data as shown here. So we have taken 1278 as the data for AND operations, and the results will be 1050. We can check it in the calculator. And for OR operations we have taken the same data 1278 and 3456, and the results of OR operation is 3678. We have taken the same data for you can take any data. So just I have taken the same data. So 12783456, and the results of XOR will be 267E. And if you take 1278 for NOT operations, the results of NOT operation will be ED87. So this is the data we assume. You can assume any data, but I have assumed this data. And let's verify the same data, so both by simulation as well as in the hardware, and make sure our program works as required. Let's go. So this is the 8086 emulator procedure. The same procedure we have done in the last two labs. Okay, so the procedure exactly is the same. New, okay. This is the program just now we discussed. Copy paste the program. We need to make 3 changes. Once the changes are done, emulate. In the emulator window, view, memory, now the content of RAM will be displayed. We need to edit the RAM address to 3000 as per our data memory update. Enter the data here. 1278 the first data, 3456 is the second data, update. Run. Now we can check the results. So the result is 1050. 1050. Now let's change AND instruction to OR instruction. Emulate. Enter the first data, same as the first one, 1278 3456, the data update. Run. Now we can verify the results at 3010, which is 367E. 367E. Let's change OR instruction to XOR instruction. Emulate. Enter the data. 1278 3456, update. Run. Now the results memory is updated. 262E is the XOR results. 262E. Now let's copy paste the program for NOT logic. Just now we discussed. Remove INT03. Emulate. Enter the data 1278, only one input 1278. 1278 should be entered as 7812. Low byte followed by high byte. Run the program. And the results memory is updated as ED87. The results will be ED87. So this is the emulator results. Now let's see the hardware results. This is the program we did in the 8086 microprocessor kit. We have taken AND logic. First we enter the programs that we discussed just now. Once program entered, now enter the data, substitute the data. 1278 3456. Now we should execute the program. Go 2000 2030. We verify the results at 3010. For AND logic, the result should be 1050, which is exactly here. Let's see OR logic. Enter the program. We directly execute the program because we have taken the same data as the previous program, so it will be in the RAM. Just execute. Now we can verify the results of OR logic. So the result should be 367E is exactly same here. You can see that. Now we take XOR logic. Enter the program. Same data. So we execute the program. We bypass step number 2. We display the results DW3010, and the result of XOR logic is 26262E, same as that we discussed. Now let's verify the NOT logic. Enter the program. We bypass step number 2, so the same data, we have taken the same data, so we do step number 3, go 2000 to 2030 and execute it. This is the execution results. We want to see the results at memory 3010, DW 3010, and you can see that the result is ED87. As that we have get it using calculator or by the simulator. So we can conclude that in this laboratory activity we have developed an 8086 assembly language program for AND, OR, XOR and NOT logical operations of 2 16-bit data, and the same has been verified using the given microprocessor kit and also using the EMU 8086 emulator. Thank you for watching.